Bismillahirrahmanirrahim. My presentation titled Titanium Dioxide Thin Films Deposited by Plasma Sputtering Process for Optoelectronic Applications Impact of Substrate Type. The presentation plan is 1. Introduction 1. Context 2. Objectives 2. Experimental part 1. Synthesis method 2. Characterization techniques 3. Results and discussions 4. Conclusion. Due to its outstanding properties such as availability, photocatalyst, biocompatibility, photovoltaic cells, high transparency, high chemical stability, titanium dioxide has been the most extensively investigated material during the last years. The objectives of my work are 1. Elaboration of titanium dioxide thin films by radiofrequency magnetron sputtering process. 2. Study of substrate type effect on the physical and optical properties of nanostructured synthesized thin films of titanium dioxide. 2. Experimental part 1. Synthesis methods of thin films. There are many methods to produce thin films. Among them, we find chemical vapor deposition, Solger process, hydrothermal method, metal organic chemical vapor deposition, pulsed laser deposition, ion beam technique, plasma enhanced chemical vapor deposition, radiofrequency magnetron sputtering. The last one were chosen by us for many advantages, among them industrial process, lower substrate temperature, good film adhesion, good uniformity of thickness distribution, film properties easily modified by doping, good quality thin films. Synthesizes protocol of TU2 thin films. First one, steps of substrate preparation. Substrates of glass, quartz, and silicon 100 are degraded by detergent and rinsed with distilled water. Ultrasonically cleaned using acetone, methanol, and deionized water. Dried in blowing nitrogen. Secondly, steps of thin films deposition. Evacuated the sputtering chamber to base pressure of 3 times 10 power minus 6 millibar. Introduction of pure argon gas at a flow rate of 3 standard cubic centimeter by minute. Deposition of titanium dioxide thin films for 90 minutes. Post-deposition annealing step at 400 degrees Celsius for 1 hour to achieve better crystallization. Experiment middle part. Characterization techniques to investigate structural, morphological, optical, and guiding properties of thin films. We use some characterization techniques like diffraction of X-ray, scanning electron microscopy, atomic force microscopy, photospectrometry, and amylase. Figure 1. Note that all thin films of titanium dioxide exhibit anatase structure with preferred orientation along 101 for all substrates types. Figure 2 shows also that crystallite size of thin films depends on the substrate type. For more information of structural characterization, Figure 3 and Figure 4 of spectroscopy Raman confirm that the crystallinity of deposited thin films depend from the type of substrate. So, thin film deposited on silicon 100 is better, which is in good agreement with the RX data. From Figure 5, scanning electron microscopy images show that the grain size is uniform, small, spherical, and change from a substrate to another. From Figure 6, the 2-dimension and 3-dimension atomic force microscopy images show that thin films are different according to the type of substrate, and we note that roughness and thickness of thin deposited on the quartz are optimal. Figure 7 shows the optical characterization where it is clear that transmission varied between 70 and 90% for both substrates in visible region, and the best transmission for the quartz substrate. From Figure 8, more optical information which are very important for photovoltaic applications are the values of band gap of glass and quartz, which are 3.50 and 3.60 electron volt, which are in good agreement with structural and morphological characterization. In conclusion, TU2 thin films have successfully been prepared on glass, quartz, and silicon 100 substrates. Structural, morphological, and optical properties have been studied. All TU2 thin films are polycrystalline, having anatase phase with a unique preferential orientation of 101. Direct band gaps were found to be 3.50 3,615 and 3,512 extroverts. Thank you for your attention.